All right, so we're going to quickly look at exercise 2. So if you remember the parent function, so that parent function for this is 1 over x. So because it has an x minus 2 in the denominator, that means we are going to shift it to the right by 2 units. And I'm still going to follow that same pattern. Okay, and something I had mentioned yesterday is that we have a horizontal asymptote as well at 0. So I'm just going to quickly sketch in the graph. All right, so moving right along, at what x value will this function be undefined? Well, we had said when x is 2, that's where we have our vertical asymptote. So that's where this function is going to be undefined. And again, we know that the vertical asymptote is at x equals 2. Quickly, just to state the domain. So as I travel from negative infinity all the way to 2, there's one piece of the domain. I don't actually reach 2. And then I'm going to continue from 2 all the way to infinity. All right, let's take a look at the range. We're going from negative infinity to 0, unioned with 0 to infinity. And how do we describe the transformation of this parent from the parent function? Well, we had said earlier that this is going to be shifted right 2 units. All right, let's move on. I'm going to skip exercise 3 just because it's very similar to exercise 2. In exercise 3, now this is shifted to the left 3 units, and you'll still follow the same procedure as before. Okay, for exercise 4, the only difference here now is the plus 2 on the outside. So this means that we have a vertical shift by 2. Okay, so vertical shift up 2 units. Okay, so I'm going to quickly just sketch that in. All right, so this is the graph that I'm looking at. I have a horizontal asymptote at y equals 2, and I have a vertical asymptote at x equals 0. Okay, so again, where would that function be undefined? When x is 0, and my vertical asymptote is when the function is undefined. Quickly, I'm just going to draw it right in the domain and range and describe the parent function, the transformation from the parent function. Well, we already said that. It's a vertical shift up 2 units. All right, and I'll just quickly fill in the domain and range. Okay, now very quickly what I want to talk about here, we will be looking at x-intercepts and y-intercepts as well. So in this example, in order for you to find an x-intercept, does anyone remember which value we set equal to 0? In order to find an x-intercept, okay, you need to know that to find an x-intercept, that means y equals 0. Okay, so I'll just write that down. All right, so I threw that in right here. So x-intercept is when y equals 0. Well, if we look at our function here, well, if I set this equal to 0, so I have 0 equals 1 over x plus 2, I'll be able to find the x-intercept. So I'm just going to quickly do the algebra here. All right, so again, just quickly do the algebra, and you'll get the x-intercept is at negative 1/2. So if I come along the x-axis, I'm actually going to label this point right here. That's the point, negative 1/2, comma, 0. And we're going to be starting to do those as well as we study this unit. All right, let's move right along to our next example. All right, so I'm going to take a look at exercise 6 now. So that's the function f of x is equal to 1 over x squared. So we actually call this a volcano graph. All right, so same rules apply. When will the function be undefined? Well, we set that denominator equal to 0. So that's when x equals 0. And similarly, the equation for the vertical asymptote is always where this is undefined. So again, we have x equals 0. And I'm going to draw in my vertical asymptote at x equals 0. Okay. Something also I want you guys to note is if you raise anything to an even exponent, the outcome is always positive. So whether I had negative 2 squared, negative 3 squared, etc., all of those values are going to be positive. So different from our other graphs, this graph is going to have all positive y values. So let's take a look. Okay, so this is what my graph is going to look like. We have all of our y values are positive. The graph is approaching 0. It gets very close to 0. but never actually reaches 0. So there we again have another horizontal asymptote, which I will get into later in this lesson. Okay, so now we have everything filled out here. Now we just got to talk about the domain. So very similar to the other problems we've done, our domain is going from negative infinity to 0, unioned with 0 to infinity. Again, we don't ever actually cross the y-axis here. Okay, and now the range. Okay, well, if you think about it, look at what the y values are tending towards. So we have, as I go from left to right, going from 0 to infinity, and then infinity towards 0. So our range of values is from 0 to infinity. So now how does this parent function differ from the other graph? Well, here, all the y values now are positive. Okay. All right, let's take a look at our next graph. Now we are looking at exercise 7. So now we have a negative out front here of that 1 over x squared. So if you recall from previous units, if I have a negative out front, that means we are reflecting this over the x-axis. And we are doing that with respect to the parent function. So from exercise 6, the parent function was that volcano graph, which was 1 over x squared. So that was that parent function. All right, so we're just going to reflect that over the x-axis. So I'm going to draw that in here really quick. All right, so that is our reflected volcano graph. And for which value of x will this function be undefined? As in all of the other examples, they have all been at x equals 0. And again, that's where our vertical asymptote lies as well. Domain now, here again, very similar to all the other problems we've been doing. It's going from negative infinity to 0, unioned with 0 to infinity. And now the range here, we are going from negative infinity towards 0, negative infinity towards 0. So our range is negative infinity to 0. And now how does this graph compare to the volcano parent function? Well, now all of our y values are negative. Okay, so now all of the y values here are negative. All right, let's move on. Okay, so now if you look at page 5, this should be pretty much a review. Vertical asymptotes, that's the line where the graph approaches but does not actually cross. And then the vertical asymptote occurs when the denominator is set equal to 0. And again, the definition of an asymptote, again, that's where the curve approaches but never actually crosses or touches. Okay, so those are the keywords you want to throw in those fill-ins. All right, so now what we're going to be looking at next are horizontal and vertical asymptotes. The oblique and slant we're going to save for another day. So our main focus right now are going to be horizontal and vertical asymptotes. The vertical asymptotes you guys should be pretty familiar with from last year, but we're still going to review that. Horizontal should be totally new for you. All right, so things you want to know about horizontal asymptotes. And you have all of the rules down there, which probably looks a little confusing, but we're going to go over it right now. So say I gave you the example of y equals x to the 4th plus x squared plus 1 all over x squared. We would call this function top-heavy because the leading coefficient, okay, so our leading coefficient term would be this x to the 4th term. And there is no other term in the denominator aside from that x squared. So the leading coefficient, that first term, it's exponent. So the highest degree here is a 4. And now the highest degree in the denominator is a 2. So we call this top-heavy. So when you have an equation or a rational function that is top-heavy, we say that there is no horizontal asymptote. Okay, so I'm going to write that down for you so that way you have it. Okay, so again, when our rational function is top-heavy, there is no horizontal asymptote. Next, we're going to look at equal heavy. So I'll give you an example of that. So if I had y equals x cubed, throw 2x cubed plus 4x minus 1 all over 4x cubed plus x squared. Okay, so this was written correctly in the right order from highest degree to lowest degree. So if we look again at that leading coefficient, that leading term, we have that 2x cubed and the 4x cubed. This is equal heavy. The degree, the highest degree of the numerator is 3, and the highest degree of the denominator is 3. So what we do here when we have equal heavy exponents, we take the ratio of the leading coefficients. So because the leading coefficient here is 2, and then the leading coefficient here is 4, that's going to be the value for my horizontal asymptote. So I'll have a horizontal asymptote at, y equals 2 over 4, which is the same thing as 1/2. So we'll have a horizontal asymptote at y equals 1/2, because again, this was equal heavy. And lastly, we've got to take a look at bottom heavy. So for bottom heavy, I'll give you an example of this. And this is all the rules that you will need to know for horizontal asymptotes. Okay, so let's take a look at something that would be bottom heavy. All right, so over here, I gave an example of something that would be bottom heavy. So now first, I don't know if you may have noticed this, but this is not written in the correct order. So I need to rearrange this. So this is actually y equals, we have to go from highest exponent to lowest exponent. So this would really be negative 3x to the 4th plus 7x squared plus 2x all over 5x to the 5th plus x. Now this we would consider bottom heavy because the exponent in the denominator is bigger than the exponent in the numerator. So because this is bottom heavy, automatically our horizontal asymptote is at y equals 0. Okay, so again, just a little recap. This is something you do need to be familiar with as we do more practice with this. All right, so here's your recap. When it's top heavy, meaning the highest degree in the numerator is bigger than the degree in the denominator, there's no horizontal asymptote. When it's equal heavy, meaning that the exponent in the numerator is at the same degree of the exponent in the denominator, we take the ratio of the leading coefficients. And then lastly, if the degree in the denominator is bigger than the degree in the numerator, we say that our horizontal asymptote is at y equals 0. Okay, so those are all of your rules for horizontal asymptotes. All right, let's move on now to vertical asymptotes. All right, so vertical asymptotes occur, again, when we set that denominator equal to 0. So if I gave you the example, x squared minus 3 all over x squared minus 4, if I were to factor this denominator, I would have x minus 2 and x plus 2. So the two values for where this would become undefined, which is also where our vertical asymptotes occur, would be at x equals 2 and x equals negative 2. Okay, and we are not going to get into the oblique slant asymptotes today, but something you may want to note for yourself is that slant asymptotes exist when the rational function is top heavy. So when we have a top heavy rational function, that's when slant asymptotes exist. And we're not going to be getting into that today. So I'll write that down for you. All right, so you have that here if you want to write that for yourself. That way you have it. Slant asymptotes exist when the function is top heavy. All right, let's move on to some practice problems here. So similar to what I had said earlier, when we now try these with the horizontal asymptotes, okay, if you notice, this first example for letter A is bottom heavy, meaning the exponent in the denominator is larger than the exponent in the numerator. So automatically that means my horizontal asymptote is at y equals 0. And that's obviously going to be the case for all of these because it's in the bottom heavy category, but let's actually go through these just to check. Okay, so if we look at letter B, all right, so this is written in the correct order. Again, you'll notice the exponent in the denominator is bigger than the exponent in the numerator. So my horizontal asymptote exists at y equals 0. And now lastly, for letter C, we do need to do a little bit of rearranging. So I'm going to rearrange my numerator and denominator. All right, so now that I rearranged my numerator and denominator, I want to look for where or what is the highest degree in both the numerator and denominator. So in the numerator, the highest degree is 3. In the denominator, it's a 4. So again, clearly, this is bottom heavy. My horizontal asymptote exists at y equals 0. So let's just draw out our conclusions here. Again, if I had my graphing calculator with me, I would be able to show you guys why this exists. But let's write down our conclusion here. So major takeaway from this is that when a rational function is bottom heavy, the equation for the horizontal asymptote is y equals 0. All right, so I'll write that down for you now. All right, so there you have it. When a rational function is bottom heavy, the equation of the horizontal asymptote is y equals 0. All right, let's move on to equal heavy and then top heavy. All right, so as I had mentioned before, equal heavy is when the leading degree in the numerator is the same as the degree in the denominator, and let's make sure that is the case. Okay, so if we look at the first example, the highest degree is 2, and in the denominator, the highest degree is a 2. So to figure out the horizontal asymptote, we take the ratio of the leading coefficients. So my horizontal asymptote here will be 3 over 4. In our next example here, you'll see, again, I have a 3 in the numerator for my highest degree exponent, and in the denominator I also have a 3. So since our degrees match, this is equal heavy, I'm going to take the ratio of the leading coefficients, which would be 7 over 5. So that's my horizontal asymptote. Why don't you give letter C a try? So for letter C, just to give you a little hint, you need to make sure that it is in the correct order. All right, so now that I gave you a few seconds to take a look at that, if we rearrange the denominator, so the numerator was fine. The denominator needed to be rearranged, so we would have the following. Okay, that's a 3 minus 10x squared plus 3. All right, so now again, the highest degree of the numerator is 4, and the highest degree of the denominator is 4. We take the ratio of the leading coefficients, which would be 3 and -8. So my horizontal asymptote will be at y equals -3 over 8. Okay, so our major conclusions here would just be that if a rational function is equal heavy, the equation of the horizontal asymptote is y equals the ratio of the leading coefficient. And I'll write that down so that way you have it. Okay, so if you want to pause the video here and just write down this information. All right, now lastly, we're just going to move on to top heavy, and then you guys will actually be able to practice some of this. So if I look at top heavy, okay, so now the highest degree in the numerator will be larger than the degree of the denominator, which is true for this first example. Here I have an x cubed with an x squared. So my degree in the numerator is bigger than the degree in the denominator. What that means is that there is no horizontal asymptote. So none. No horizontal asymptote. And obviously that will be the case for all of these since this is in the top heavy category, but let's actually verify why. Okay, so if I look at letter B, okay, again, the highest exponent here is 4, and the highest exponent in the denominator is 2. For letter C, we have to rearrange our terms. So again, this is not written in the correct order. So this should have been 7x cubed plus 2x squared plus 8x minus 7. And that denominator should have been written as -7x squared minus 8x plus 6. Where again, the highest exponent in the numerator is bigger than the one in the denominator. Okay, so I'll write down our major conclusions here, then we'll actually do some practice. All right, so there you have it. If you want to pause the video here, that way you have this information written down. We're going to do now some actual practice problems and applications. So let's go to page 7. All right, so let's look at question number 1. So I have 2x minus 3 all over x plus 1. So the vertical asymptote is usually the easiest, so let's do that first. Vertical asymptote is we're just trying to find when this thing is going to be undefined. And that's going to be when that denominator is equal to 0. So when my denominator is equal to 0, we know what our vertical asymptote is. So when x equals -1, this will be undefined. So I'm just going to write that my vertical asymptote is at -1. Okay, now I want my horizontal asymptote. So the horizontal asymptote requires us to know those rules that I had mentioned earlier. So since the exponent in the numerator is the same as the exponent in the denominator, this is considered equal heavy. So I'll write that in here for you. This is equal heavy, meaning we're just going to take the ratio of the leading coefficients, which is going to be 2 over 1. So my horizontal asymptote's at 2. Okay, let's look at another example, like question number 2. Okay, so again, let's find that vertical asymptote. That's usually the easiest thing to find first. So we want to set this denominator equal to 0. So when I factor this out, I will get x minus 3 and x plus 2, meaning that my x values are at 3 and x equals -2. So those are my vertical asymptotes. Now I want to find the horizontal asymptotes. So again, we've got to apply those rules here. So for this first example, well, the degree of the numerator is 1 and the degree of the denominator is 2. So this is bottom heavy, meaning that my horizontal asymptote is at y equals 0. All right, so we've done an example with equal heavy. We've now done an example with bottom heavy. What do you think is coming next? Yes, we are going to do now top heavy. Okay, so let's look at example number 4. All right, so for example number 4, again, we want to take a look at those vertical asymptotes. So I'm just going to write in, we have the vertical asymptote is going to be whenever this thing is equal to 0. So that's when x is going to equal 1. Now I have to take a look at my horizontal asymptote. Well, because this is top heavy, again, because if you take a look, the exponent here is really to the first. So because this is top heavy, there is no horizontal asymptote. Again, I don't know if you remember I said this earlier, but that means there would be a slant asymptote here. Okay, but you don't really need to worry about that right now. All right, and that's kind of everything I have for today. I would encourage you to try the rest of the problems on this page, and we can go over any questions that you guys have tomorrow. So again, I would encourage you to try to finish up the questions on this page, and I can go over whatever you guys need help with tomorrow. All right, hope you enjoyed this video. See you tomorrow. Bye.